Graphing polynomial functions. Let's consider the following polynomial, y equals x cubed minus 4x. Graphing polynomials requires us to find a few key features of the graph. One thing we want to be sure to find is all x-intercepts of the graph, and also all y-intercepts of the graph. Now remember, when a function crosses the x-axis, y is always equal to 0 at that point. So the way we find an x-intercept is we let y equal 0. And likewise, the way we find a y-intercept is we let x equal 0. So let's go ahead and find the x-intercepts first. So if I let y equal 0, we get 0 equals x cubed minus 4x. And we can solve this equation by factoring. So we can take out an x here and get x times x squared minus 4. Further factoring gives us x times x minus 2 times x plus 2. And finally, if we set all of these factors equal to 0, we end up getting x equals 0, x equals 2, and x equals negative 2. And so there are 3 x-intercepts, and I'll go ahead and put those on the graph here. And then the y-intercept, you might notice that we've already found the y-intercept. So the point here is the origin. That is the point where the graph crosses the x-axis, but also crosses the y-axis. But the way you would do this is you would just simply let x equal 0. And of course, in this case, y would just become 0 cubed minus 4 times 0, which is 0, right? So we know the y-intercept is 0, as I mentioned. So now the question is, what does this graph look like? How does it go through these 3 points? Well, polynomials always have nice, smooth, predictable behavior. So this graph is going to go something like this, where it goes through here, and then back through here, and then here. Or it could possibly go something like this, very similar, but a different tracing pattern there. So how do we figure out which one it is? Well, there's a couple of different things you can do, but the easiest way to figure it out is just to plug in some additional values of x and see what you get for y. So for example, I can plug in x equals negative 1, x equals positive 1. I could plug in x equals negative 3 and positive 3, and actually all of those would be really good points to plug in. And so we're just going to plug those into our function. So when x is negative 3, y is going to be negative 3 quantity to the third power minus 4 times negative 3. This is negative 27 plus 12, which is negative 15. If x is negative 1, y is going to be negative 1 to the third power minus 4 times negative 1, which is negative 1 plus 4, which equals 3. And if you plug in 1 and 3, you are going to get negative 3 and positive 15. You can double check the math on that. And now let's go ahead and graph those additional points. So when we plug in x equals negative 3, we get y equals negative 15. So negative 3 is right here. Negative 15 is way down here somewhere. So I'll go ahead and erase this and put a point down there. So let's see, negative 3, negative 15 is maybe down here. And then we have negative 1, negative 3. Negative 1, positive 3, this one right here. Negative 1, positive 3 is this point. The next point is positive 1, negative 3, which is down here. And finally, we have positive 3, positive 15, which is way up here somewhere. So it is apparent that this graph comes up something like this, goes through the x-axis at that point, turns around, goes back through the x-axis, and takes off after that. So graphing polynomials is not extremely difficult, but you always want to make sure you get your x-intercepts and your y-intercepts, and then, as I mentioned here, a few additional points on the curve, and then they are pretty simple to sketch. So for this next polynomial function, let's go ahead and start by finding our x-intercepts. So remember, to find your x-intercepts, you're going to let y equal 0, which is the same thing as letting f of x equal 0. So here's our polynomial function, x cubed minus x squared minus 9x plus 9. And when we let f of x equal 0, we're just setting this equal to 0. We can actually solve this equation by factoring. I can factor out an x squared here. And out of the second two terms here, I can pull out a negative 9, and that's going to give us x minus 1. Notice that you have x minus 1 left over here in both places. So now if I factor out the x minus 1, we have x squared minus 9 left over. And then x squared minus 9 can be factored into x minus 3 and to x plus 3. And if we set all of those equal to 0, we will end up getting 3 x-intercepts. So x equals 1 is an x-intercept, x equals 3, and x equals negative 3. Now let's also go ahead and find the y-intercept. And to do this, we let x be equal to 0. So a little bit different. What we're doing here is we're plugging 0 into the function. So we're finding f of 0, which is 0 cubed minus 0 squared minus 9 times 0 plus 9. And of course, that tells us f of 0 is equal to 9. So the y-intercept is at the point 0, 9. Now, if you'll notice, I already kind of know what this graph is going to look like, right? Because we know it has to go through this point, and then it has to come up here and touch this point, right? So it really can't be going this way, can it? Because if it went this way, it would have to turn back around and come up to hit this point, but it can't do that because we don't have any other x-intercepts here. So we know it must be going up through the x-axis here, hitting this point, turning around and coming down, and then coming back through this way. Now, the truth is, we don't really know for sure where this graph turns around, right? It may not turn around right here. It might actually go up a little bit higher and then turn around. So if you want more detail, of course, you can plug in these values of x here to get more points on the graph. But right now, we're really mostly just interested in getting a rough sketch of the graph. So I'm going to just sketch what I believe to be a rough sketch of that graph. And of course, if I want more detail about, how far it comes down here, I can plug in more numbers into the function and get more values and more points to graph if I want to. But again, for right now, we're just kind of like going over the basics of graphing polynomials. So for our next one, we have y equals x to the fourth minus 3x squared. Now this one really is a little bit different. So again, let's go ahead and find our x-intercepts by letting y equal 0. So we get x to the fourth minus 3x squared equals 0. I can solve this by factoring out an x squared, which gives us x squared minus 3. And then if I set x squared equal to 0, that's going to give us x equals 0. And if I set x squared minus 3 equal to 0, that gives us x squared equals 3. And taking the square root of both sides gives us plus or minus the square root of 3. And that is about plus or minus 1.7. That's an approximation, okay? So we have 3 x-intercepts. We have 0, and we have 1.7, which is right about there, and negative 1.7, which is right about there. And I'm not going to bother with finding the y-intercept because I already have it right here. So what does this graph look like? So to understand this one, let's go ahead and plug in a few additional points here. So I have x and y. Let's plug in x equals negative 2, negative 1, positive 1, and positive 2. So when x is negative 2, y is going to be negative 2 to the fourth minus 3 times negative 2 squared. This is positive 16 minus 3 times 4, which is 16 minus 12, which is positive 4. Okay? Now, let's go ahead and plug in positive 2. So positive 2 is going to give us 2 to the 4th minus 3 times 2 squared. Notice that this is also 16 minus 12, which is also 4. And if I plug in x equals negative 1, y will be negative 1 to the 4th minus 3 times negative 1 squared. This is 1, take away 3, which is negative 2. And if you plug in positive 1, you are going to get negative 2 as well. So we have these points, negative 2, positive 4, right here. Negative 1, negative 2, which is down there. Positive 1, negative 2, which is also down here. And positive 2, positive 4, which is up here. So what's going on here? Let's think about what the graph looks like. So we know that from this point, we're coming down and we're going through the x-axis, right? We're coming down here, coming back up. And what's going on right here? And are we going through the x-axis? If I go through the x-axis, then how am I getting to this point? So I must be just barely touching this point and then turning around and going down to this point and then coming up through the x-axis again, right? Think about that. That's the only thing that's possible here. So this curve must be doing something like this, coming down, going through there at that x-intercept, coming down here, coming back up, and again, just touching here, turning around because we've got to go back down to that point, and then coming back up again and continuing from there. So how do we know that this is happening? I mean, it seems logical from the points that I've chosen, but there is a way to know why this is happening. And here's why. 0, x equals 0, comes from this equation. Notice that we had x squared. We didn't have x. When the power of your factor is even, then when it touches the x-axis, it's going to do just that. It's going to touch and turn around. When the power of your factor is odd, it's going to completely pass through. So I want you to notice that I could have factored this a little bit more. X squared minus 3 actually does factor into x minus radical 3 and x plus radical 3, right? And that's why we got the answers that we got down here. But each of these are raised to the first power. So when the power is odd, whatever x-intercept, whatever 0 of the polynomial is coming from that factor, it's going to completely pass through the x-axis. But if the power is even, it's just going to touch the x-axis and turn around. So that's how we know the difference between the behaviors of the various types of x-intercepts. So for our last one here, let's go ahead and graph this polynomial function. Once again, we're going to find the x-intercepts of our graph. So we're going to set our polynomial function here equal to 0. And let's go ahead and factor that. So I'm going to factor just by using some trial and error here. I know x to the 4th is x squared times x squared. And I know that 9 could be 9 times 1. And if I go, 9 times 1 here. And if I go negative and negative, that's going to give me a positive 9. And in the middle here, I'm going to get negative 9x squared and negative 1x squared, which is negative 10x squared. Now we can go ahead and factor this a little bit more. X squared minus 9 factors like this. X squared minus 1 factors like this. And we're going to get 4 answers, 3, negative 3, 1, and negative 1. And if I graph all those, here's negative 3, negative 1, positive 1, and positive 3. Notice that all of these factors are raised to the first power. That means that whatever's happening here, these are passed through, right? So the graph is coming and passing through that point. It's not just touching and turning around. Now, one more thing that'll be very helpful here is let's go ahead and find the y-intercept. To get the y-intercept, we just let x equal 0. And notice when you plug 0 into a polynomial, basically what you get is you just get the constant term. So g of 0 is equal to 9, and that point is up here. Now let's think about what that tells us. So we know that the graph has to go through this point. It's got to come down. It's got to completely pass through here, down to some level, and then it's got to come back up. And once it passes through here, that's it. It's going to continue rising forever after that. So it must be doing something like this. And then on the other side, it's the same thing. Okay? Now again, don't judge the graph too much by down here. I don't know if it comes down that far or if it comes down a little bit farther. If I really want to know the answer to that question, so if I really want a very accurate graph, I would have to plug in a point like x equals 2. I can do that really quick here. If I do that, I get 2 to the 4th minus 10 times 2 squared plus 9. This is going to be 16 minus 40 plus 9. This is actually negative 15. Okay, so my graph is way off, right? It's actually way off. But again, for the main behavior of the graph, it doesn't really matter. We're just trying to capture the essence of what this polynomial function looks like. But at positive 2, it's way down here at negative 15. And at negative 2, it's also going to be way down here at negative 15. So the graph actually looks something like this. It's a little bit embarrassing, if I'm just being totally honest. Okay? But again, what we're really looking for is where does it cross the x-axis? Where does it cross the y-axis? And what's the general behavior of this graph? Okay? So we're using a lot of factoring, or you can use synthetic division to find the zeros of the polynomial, which equate to the x-intercepts in the graph. But this is an introduction to graphing polynomial functions. And that concludes this video lesson.